Hello to you all awesome matriculants. Welcome to This is Learn Extra Live, your favorite show, and it is all about physical sciences. My name is AB, better known as Abram, but I'm joined by Tracy. How are you, Tracy?
Fine, and you, AB?
I'm also good. It's the last term. How are you feeling? I heard you were crying.
Why?
Because it's the last term.
Well, you know what? All my babies are darn grown up now.
Okay.
I told them today. When I saw my babies, I was like, they all did go grown up now.
Aww.
And so all my babies are adults, and I miss my baby.
Well, there's no more time for them except revision now. There isn't much work that they need to do except revising.
Revise.
Are you feeling good though? Do you think they are ready in a way?
You know what? I think it depends on how much they've done. So if they take note of what we're doing the next couple of shows, like today and Saturday, we're going through the physics prelim paper, art questions. We can't do all of it. It was a long paper. But now it's just revision, practice, and practicing under exam conditions.
Yes.
Not with your book open. So the more you practice without a book and get them right, the more confident you're going to feel.
Nice one. Talking about revision, Mindset has partnered with Samsung to make sure that you have your revision package all handy at all times. Now I'll be taking you through to the Samsung Learning Hub, how it looks like. You can access it on your Samsung tablet or your premium smartphone. This is how it looks like. When you get to the material that you like or the content that you like, you'll see a document more like your own question, your normal question paper, and then you can browse through on it. You can answer the questions. It's interactive. I can answer in it. Then the nice part also about it, you see, I can see my answer if I'm wrong or not. Can also check the marks. But the nice part of it is that you can also check the videos. As you saw that I was having a video that was playing. You see a video at the same time. You've got two screens that are playing at the same time. How nice is that, Tracy?
Oh, man.
Because at times you're working and you have only one device that you're using, so you can't see the video and the question paper at the same time.
I think it's great. I just think in terms of that's who doesn't have a tablet these days, pretty much.
Or a smartphone anyway,
some sort, yeah.
a premium smartphone. But it doesn't end there. As you see the video that is playing on your device, you can also view all the material that we have. So this is how you view the material. You go to the Learning Hub, your Samsung Learning Hub on your tablet, and then you go to you'll see a shelf with the books that you have. If you don't have any other books, you still have some space to put on more books or content. You go to the store. When the store opens, you'll see there's a category and brands. What you do is you go to brands. You'll see all the brands that are there and look for Mindset Learn. Then you click on Mindset Learn. When you click on Mindset Learn, you'll see all the products that Mindset has. You can view them and you can also purchase them. So for instance, you view that you like life sciences and then you'd like to see what more do we have on biotechnology. You can view that and then you can also buy it. We have a free voucher that you can access, which is worth $100. So learning is easy and accessible. And once you purchase this, it will be on your bookshelf and you can access it at any time. That's a great innovation from Samsung.
That's amazing. And 100 Rand with things only being what, 8, 9 Rand?
8 Rand 37.
That's like you can get 10, 12...
So many stuff.
Books and stuff. It's unbelievable. I think it's actually
I'm
amazing.
glad you mentioned that, Tracy, because on that voucher, you need to use it once and you need to use all of it. If you just use 10 Rand, it means you'll lose 90 Rand. So better use it all. But without any waste of time, as Tracy have said that we are going over some prelim reviews, I need to tell you that it is proudly sponsored by Macmillan and you can have your notes all for free on learnextra.co.za/live. Otherwise, chat to me on Facebook. Our Facebook page is facebook.com/learnextra. Like the page and let's get interacting. But otherwise, we have also the help desk where you can submit your questions on Mixit, now available on Mixit. Look for it under the general contacts, edit, because we always want to help you. Thanks a lot to Macmillan for making this show possible. Tracy, over to you.
Sorry, I'm just busy getting a bit lower.
No
anyway,
problem.
moving on. Guys, seriously, make use of the fact that you can get our notes, that you get everything's there. Make use of Mindset. This is your last big push. You've got about 4 or 5 weeks before we write your finals for this one.
Yes.
It's okay. Last big push. Now, like AB said, we're going to do a little bit of physics prelim review, and specifically we're looking at the GDE prelim. So those of you who wrote the prelim, hopefully you got them back today. So you've maybe had a little bit of review with your teachers. I don't know. Those of you who are from other provinces, you know what? That's okay. You can bear with us. Remember, these notes are online, so you can actually get them. So if we start, what we're going to do is we're literally just going to do some questions from the 2013 prelim exam. Okay? And what we've done, we're not going to do them in order. So I'm not starting with question 1 and question 2 and the one-word answers. What we've decided to do is we decided to pick out the sections that we feel, and I'm obviously looking at it from my own learners, I have quite a few, but also the things we feel like where the common mistakes would come in and the sort of questions that might have been a little trickier, a little different to what you're used to. So we're starting with the Doppler effect, okay? Now, I'm a bit of a meanie, okay, because I thought this was a stunning Doppler question. I loved this question. I don't think too many other people did. And in fact, I know my own learners really struggled with it. And not because it was necessarily more difficult, but simply because it had a reflection in it. But it's a stunning, stunning question. Something a little different. And it's not the usual ambulance or police car or racing car or something different. So to say to you, a submarine is stationary. So first thing is, let's find the important words, okay? So okay, the board is playing with me, okay? So the submarine is stationary on the seabed as shown in the diagram. The sonar system of the submarine detects a whale moving towards the submarine at a velocity of 10. So the whale is moving at 10, submarine is not moving. Okay, so that's very important. The sonar system operates at a frequency of 2,3 times 10 to the 4 hertz. So that means that the frequency of the source is 2,3 times 10 to the 4 hertz. Take the speed of the sonar wave in water as 1,435. This was the nice thing, is because here they're saying to you, don't use the speed of sound as 340 or 330, but you're going to take the speed of sound as 1,435. So that's B. For now, I'm going to make that my source, so the whale becomes my listener in a usual situation. Now it says, describe the Doppler effect in words. Now there's a couple of really, really important words that you have to put into the Doppler effect. The Doppler effect is the apparent changing frequency of a sound due to the relative motion between a source and a listener. Okay? Now, it was only worth 2 marks. Please, that doesn't mean you're writing a paragraph. It doesn't mean you're writing a page. It means you're writing something really short and sweet and to the point. What are we looking for? It is the apparent change in frequency. Remember, the only thing that can actually change the frequency of sound is the source. So the only way this frequency can actually change, is if the sonar produces a wave of a different sound, okay, which it's not going to do. So it is the apparent change in frequency due to the relative motion of a source and the listener. Now, why do I say relative motion? Because either the source can be moving and the listener stationary, or the listener is moving and the source is stationary, or, which we don't do in our calculations, they can both be moving. But there's got to be motion. Okay. Now for the fun part. Now it said to you, calculate. Oh, man. Wow. The board is having a moment again. Sorry.
Are you sure?
Yes. It's not just me. Stop it. It's not just me. Okay. Alrighty. Okay. Anyway, when it decides to when it decides to move, the question says to us, calculate the frequency detected by the sonar when it's reflected back. So, there we go. You see, it's having a very slow moment.
It's fine. We'll fix it for you.
Yeah, it's just okay. So basically, let me see if I can write on it, and hopefully, no, it doesn't even want me to write. So I'm not sure what we should be doing right now, because I actually, there we go. Okay, take away. Bear with us. Okay, so what I need to recognize, I would draw you a picture, but that could take us till Christmas. The
All right, you know what, Tracy, let's just get over
Yes,
Facebook and see what's happening while you're trying to fix that. We have some couple of comments. We see, so hey, Tracy, ready to study now. That's nice. And Sabelo is saying they're more than ready, otherwise feeling excited. Here's a question from Torofato saying, where can I get a Samsung tablet on prepaid everywhere, mindset, and make sure that you get it. But otherwise, I must say this great news are, since we've partnered with Samsung, we're bringing you an awesome marathon competition during our exam score. So be on the look for that one. And as we are helping you, remember, mindset is we are always here for you. Don't stress. It is the last term, but also as we are giving some giveaways, Samsung is on board. So there's a great stuff that we are having for you. Otherwise, I must look at some of the questions and comments that I have. And Teboge saying, hello, I'm so excited because I so love physics. You know, that's great. That's the spirit that we want. I don't want you guys to be missing out. Remember that we are only left with 26 days before you write your exams, officially so. So be on the look, because time is no longer on our side, because we always want you guys to be ready. So make sure that you push through your questions that you have via our help desk. We have Mix It. But otherwise, I think we should get... Oh, you are fine now.
We think so.
I thought I was about to take an ad break.
Well, no, we're sorted. Let's go. Anyway, so it says, calculate the frequency of the signal received by the submarine after being reflected by the whale. So what you need to recognize here, grade 12s, is the wave goes to the whale, okay? The whale then reflects the wave back. But the whale is not going to experience 2.3 times 10 to the 4 hertz. That's not the frequency of the wave it's going to reflect back. It's actually going to be a higher frequency, because the whale is moving towards the submarine. Now, for the first half of that, first thing we're going to do, let's ignore the reflection. First thing I'm going to do is, if I just said to you, what is the frequency of the wave heard by the whale? Okay? We'd be okay with this, because my source is 0, my listener is going at 10, and my source has a frequency of 2.3 times 10 to the 4. So, okay, there we go. So the first thing we're going to do, okay, so this is heard by the whale, okay? So we're looking at what happens with the whale. Remember, the frequency that the listener experiences is plus or minus the frequency, the velocity of the listener, the velocity of the sound, plus or minus the velocity of the listener, divided by the velocity of the sound, plus or minus the velocity of the source, times by the frequency of the source. Write down the equation as given in your information sheet. We want the velocity of the listener. So now we've got to make some decisions about what goes in the middle over here. So first of all, the bottom's easy, because the source isn't moving, okay? So what happens here is, remember that the speed of sound is, that was terrible, is 1,435. Source isn't moving, so put the 0. The frequency that the source has is 2.3 times 10 to the 4. Now we've got to make a decision. Do I add the 10 from the whale, or do I minus the 10 from the whale? Well, now we've got to say to us, well, the whale is getting closer to the submarine, so we must add the 10, because I need this number to get bigger. So I need a big number divided by a small number. So this is 1,435 plus 10, and we get, and I'm just going to write the whole thing out. You can leave it in scientific notation, that's fine. Just make sure that you include enough decimal places. But I would suggest you write it out, because it's not a very big difference, okay? In fact, it's only 160.3 hertz as a difference. So it's not a very, very big difference. But if we look back at the whale, okay, the whale is now reflecting that back to the sonar. The whale is now the source of the new sound, okay? So when we go to over here and we say, well, what do we hear by the sonar, okay? And I didn't leave myself enough space here, but that's okay. We still need the same equation. That hasn't changed. What has changed is the source and the listener. The listener is now the sonar. The listener isn't moving. So this is 1435 plus 0. The source is the whale, and the whale is moving and is getting closer. So now I'm going to minus, because I need a small number at the top. And this value is the one I've just worked out, which is 23. There we go. And I get 23322.8 hertz. Okay. I loved this question simply because it had the... Sorry, I'm having a very untechnical day today. It's fun. It's one of those days. It's first day back. Okay, guys, I love this question because of the echo and the fact that you needed to recognize that the whale became the new source. Okay, the whale became the new source. So if we go back, can you see what I've done on my diagram? I drew and wrote all over it. This is what we expect your question paper to look like, because you need to work through it. You need to work through what is it that they're asking me? Why are they asking me that? Remember, I said, what's the echo? So I knew it had to go there and then it had to come back. So you have to think through it. This is a difficult Doppler question, okay? I think this is probably one of the most difficult ones I've seen in a while, but it's a really nice one. And that's quite mean of me. My kids hate it when I tell them I'm going to give them a nice test, because then they think I'm just being mean. Okay, then the next question was, name one other use of the Doppler effect. I think this should be drummed into your heads, okay? Probably the most popular use that most of you will know is for scans on moms to be when they look at their babies in their tummies, and those are quite beautiful. If you're a girl, if you're a boy, you're like, it's a big splotch, basically, you know. Let's be honest, I often have to ask my friends, where's the baby?
Ouch.
Oh, it's there. Okay.
Ouch.
They all look
Tracy.
the same to me when they're little, when it's like 12 weeks or whatever, you know. It's difficult to see these things. I haven't had a baby, what can I say? But things like, let's move on before I completely embarrass myself. My friends all know this.
No
It's great.
comment.
No comment. Too late. Bats use it. Dolphins use echolocation using sonar. Doppler flow meters, which are used to check clogged arteries and veins. They use it to check the heart before they do open heart surgery. Lots of medical uses. It is not an X-ray, okay? Please understand that. X-rays are not Doppler has got nothing to do with Doppler, okay? It's not an X-ray. Do not put X-rays, okay? This, in the official memo, they said that it's used by blind people to understand whether a vehicle is approaching. I have to be honest, I'm not sure if I would have accepted that or put that into the memo myself, simply because it's not, you know, I mean, I can understand that blind people can really distinguish frequencies unlike us, because their hearing would be better, but I think it's a bit iffy. Rather things like bats using echolocation, dolphins using echolocation, looking at the fetus in a mom's womb, all of that sort of stuff, okay? Those are nice. It was 1 mark, nice and easy, not difficult, and it said one other use. So you couldn't use sonar, okay? You couldn't use sonar in any form, okay? So make sure. Also, radio speed guns, which are not speed traps. Those are also ones that use Doppler. Okay, and I think we can let them have a little break, and then we're going to do some diffraction.
Okay, nice one. Mindsetters, stay tuned, because we are still going to learn more, and tell your friends that we're learning. Don't be selfish. See you after the break. Welcome back, grade 12s. I hope you're enjoying what we're giving you, the prelim session that we're having for you. But otherwise, we know that a lot of you have made a lot of mistakes on their prelims, because we're writing different question papers, of course. But now, to help you as Mindset, we're having our own prelim review for 2 weeks, starting from this week up until next week, including Saturday. So on Saturday, we're having a full day package just for you on different subjects. We have maths, physical sciences, life sciences, accounting, geography, maths, lit, and just that for you, Mindset, the whole day, including Saturdays. That's so nice.
And I'll be here on Saturday.
You'll be here. I'll be here with you.
Oh, yay, I like it.
In the morning.
But he's getting a bit Kenny's older at him. We have to be careful. He's like, thinks he's the director.
I'm only coming because you'll be here on Saturday and the mind tutors will be here.
Yeah, what can we say? Anyway, moving on. And of course, physics is my favorite thing to do. So it's like, yay.
Physics and maths are my favorite too.
Oh, absolutely.
Yes.
I should be a maths teacher, but I'm a very bad maths teacher.
No.
No, I am. I'm a terrible maths teacher.
Then you shouldn't be.
No, I'm a qualified maths. No, let's not go there. I'd
Okay.
rather teach. No, this is far more fun to teach. Anyway, so let's go to question 2, which is question 7 from the GDE, and now we're looking at diffraction. Okay, and I quite like this one because it had things to do with an experiment. You had to draw a picture, which had to make sense with some labels, and then you also had to do some calculations. Okay, very typical type question, but very typical errors that you can make along the way. Now it says, diffraction of light has a significant effect on the sharpness of photographic images. So they're putting it into context for you. During the study on the effect of the width of the slit on the degree of diffraction in the laboratory, a single slit with a variable width is used. Monochromatic light with a wavelength of 7.3 times 10 to the minus 9 meters. Oh, we like these guys. They've already put my wavelength in meters. Is used to illuminate the slit. In other words, they have 7.3 times 10 to the minus 9 meters monochromatic light, which passes through the slit, okay? The resultant diffraction pattern is observed on a screen 2.5 meters away from the slit, okay? First thing is write an investigative question for this investigation. First of all, it's a question, guys. So this isn't an aim, this isn't a hypothesis, so you have to ask a question. So you have to say, what is, how does, those sort of things. You've also got to be careful, you've got to end it with a question mark, it's a question, but you cannot ask a question that gives a yes or a no answer. Now, what are we looking for in the investigative question? We're looking for the fact that you understand there has to be a relationship between the dependent and the independent variable, okay? So, dependent variable is the thing we measure, independent is the thing we control to change. Now, here it says a single slit with a variable width. That is the independent variable, okay? So the question becomes, how does the width of the slit change the diffraction or change the amount of diffraction? Okay? You can't ask, does the width of the slit affect the amount of diffraction? Because that's a yes or no answer. You need to ask a question that requires an answer like, the slit width is inversely proportional to the amount of diffraction or proportional to the amount, where you have to have a relationship. In fact, your question could be, what is the relationship between the width of the slit and the amount of diffraction experienced, okay? The examples they gave on the official memo was, how will the angle of diffraction change when the slit of the width is increased, okay? How will an increase or decrease or change in the slit width affect the amount of diffraction? What is the relationship between them? So you can't use does, is. You can't say, is there a relationship between? So when you read your question, when you go back and look at it and you read the question, if you can answer the question with yes or no, you're wrong. Okay, you don't get the marks for that. It's got to be a question that has to be answered with a full sentence. Okay, then part 2. Sketch a label diagram showing the positions of the bright and dark bands as observed on the screen. This is a little bit of an artistic thing. Now remember, I can't draw, okay? So what are they wanting? They're wanting you to recognize, well, we have our central wide band, okay? We're then going to have a dark band. Then we have a bright band. Then we have a dark band. Then we have a bright band, which is getting a little bit narrower, okay? And so we have to have exactly the same on this side. Okay. Now we all know I can't draw to save my life. So we're sort of getting the idea. So I would color this in. Okay, this is your artistic moment for the exam. Okay. Alrighty, but that's not enough because the question said draw a labeled diagram. So This is my central bright band. Okay. Then we can go, these are my alternative dark bands. Those are my light bands. Okay, so what are we looking for? Okay, is central bright band, dark bands, light bands on both sides getting narrower and smaller as you go along. Okay, central band being significantly broader. That's what they're looking for. If your diagram makes no sense, then we can't give you marks. If there are no labels, we can't give you marks. So please read the question carefully. So you've got to do sketch. So it does not have to be a work of art. Okay, it's a sketch. A labeled diagram which shows bright, dark bands on a screen. Highlight words, underline words. Okay. Now, calculate the width of the central. Oh, look, I've gained some stuff at the bottom of my page. Brilliant. It's gone now. Calculate the width of the central bright band with the slit width, when the slit width, is 0.05 micrometers. Yeah, they were horrible here. So that's 0.05 times 10 to the minus 6. What are they asking? So if we draw a diagram, I don't know how you would answer this without some sort of diagram, grade 12s, but that's just me. I think visually, so I need to see it. Basically what they're saying is, here's my screen, my slit is over here, and remember, you would have seen a diagram that does this before. There's theta, and what I want is, what is that width? Okay, more than one way to put this. I would call this x, because it's going to make my life easier. Remember they said it was 2.5 meters away from the screen, and this is A. Earlier on, they said that the wavelength of the wave was 7.3 times 10 to the minus 9 meters, okay? So when we look at this and we go, okay, I need this, I need x, which I'm then going to double. To get x, I need to know theta. To get theta, we start here. Sine theta equals m lambda over a. Okay? I need theta, so sine theta, m is going to be 1 because I'm looking for the central band. So m is 1. Lambda is 7.3 times 10 to the minus 9. And a is 0.05 times 10 to the minus 6. This is now a calculator issue, because from here I need to find theta. Okay, so we do have a calculator which was going to come up. Okay, and let's just, okay, it is off, good. All right, there we go. So I need to find sine theta. Okay, so I'm going to go second function sine. This means I'm going to get the angle straight away, okay? And inside there, I'm going to have 1 times 7.3 to the minus 9, all divided by 0.5 times 10 to the minus 6, okay? No, I don't need it. Second one, equals. That's my angle. Okay, so I've done it all in one go. My angle's 8.4, okay? Because remember, when I round this off, I would have to round the 9 up. So this becomes 8.4 degrees, okay? Theta over there is 8.4 degrees. Now we're going to use tan, because I've got opposite over adjacent, okay? So tan theta is equal to x divided by 2.5. So this is tan 8.4 degrees equals x divided by 2.5. So we go back here, which means I'm going to go 2.5 times tan, there it is, 8.4. and we get 0.37, okay, from the rounding off, 0.37. But we're not finished. And for most of my learners, this is where they stopped. But remember, if we look at my diagram, x is only this top half. It's only this part. I need the whole of it. That's also x, okay, because that splits it in half, which means that the width is twice that. So it's 2 times 0.37, which means it's 0.74 meters. Please don't change it to centimeters. Don't change it to millimeters. Don't do that. Just leave it as meters. That's the actual value for it, okay? So you get 0.74 meters, okay? Now, the next question, which is actually such a nice question because it really is putting your science into context, okay, if the board will move. Telling you the board does not like me. Anyway, so a photographer found that the width of the opening or aperture of the camera will either increase or decrease sharpness, clearly identifiable edges of the images. Now, diffraction causes blurring of images, okay? And this is what we've got to get in our heads, is for a lot of us, we go, well, if there's diffraction, and probably when we did it in class, when we had a nice small slit, we saw a really nice clear pattern, which is great because it helps explain it, but that doesn't help us with photography. Remember, with photography, we want clear lines. We don't want the light to spread. We don't want it to go all over the place, because as soon as we have lots of diffraction, the light starts to interfere and we get blurredness, we get all the funny shades. It's not pretty. So we don't want a lot of diffraction. So what needs to happen here is we need to now decide, because it says to us, how should the photographer adjust the aperture setting for the camera to increase the sharpness of the image in the photographs he takes? Write down, increase, decrease, or do not adjust, and then explain. Remember, we want to increase the sharpness, which means we must decrease the diffraction, okay? So that means to get less diffraction, I must have a bigger opening. So in other words, I must increase the aperture, okay? Why? And I'm going to do it in a shorthand, which I'm sure you can follow, because if I increase the aperture, if I increase A, it means that we're going to have less diffraction, which then means we're going to have a sharper image. Okay, less diffraction, sharper image. Bit of a mean question, because this really is a context thing, but you needed to think through what you're actually seeing. Think about, some of you are learning to drive or have already got your licenses, you drive at night, and you know that when you're looking at the lights coming towards you from other cars, they often look blurry around the edges. That's diffraction, okay? And you get lots of that diffraction because there's lots of tiny slits on your car windscreen. If you could get rid of all the scratches on your car windscreen, you wouldn't see that much diffraction. It would be clearer, okay? The less diffraction you have, the greater the clarity of the image, which means bigger gap, less diffraction, sharper image, okay? That one's a little bit different to the rest, but the other questions that we had, very typical of the type of things you can get in the exams, okay? AB?
Yes.
Time for a break.
Really?
Yes.
And we have a mindset that says,
Okay.
you know what? No. No break this time.
No break this time. I need a break. I'm getting old.
I'll try and get the name. I think it's Steviso.
No break,
Steviso
eh?
says, you know what? Yeah, it's actually Silelo, Marumo Brilliant. He says, oh no break, please.
We've got to pay the bills somehow, sweet pea.
Sorry, mindset. I'll see you after the break. Welcome back, matriculants. Now, two things that I need to explain to you about the Samsung Learning Hub. The first one is that you need to be using a Samsung tablet or a Samsung premium smartphone for you to have it. It's on your Samsung apps, and then you look for the Learning Hub on your Samsung device. So if you are using a Samsung, that's how you access it. There's no link, guys, that I can send you for now. But keep your questions coming, because greater stuff are still coming and the competition is coming. Everyone is asking me, what's up with the competition? You know what? Keep your eyes peeled on the page, because we have a marathon competition that is proudly sponsored by Samsung coming your way. But Tracy,
thank you.
You didn't know that?
Not what?
Oh, I thought you didn't know.
What?
That we have a competition that is going to come.
There's always a competition that I'm not allowed to enter.
Same
It's
here.
not fair.
But already I have my Samsung tablet, so
Oh, see,
unfortunately.
I don't have one. I have to be honest, though. I do have a Samsung computer. My laptop's a Sam, and I love it to bits.
But you must buy a Samsung premium smartphone, the latest smartphone.
I'm gonna get myself into trouble if I say the next.
All right, it's fine.
Sorry, I have
everyone will donate for you.
I have a particular preference to my smartphone.
All right, let's not go there.
Yes, because we'll get into trouble.
It will just be a Christmas present from us to you.
Oh,
I'm just
Do you realize you said that? But how many thousands of views? I've got that. I've got that on public television, and it's gonna go on the internet. I love it.
Let's take some questions. Can you stick to business?
I'm making you blush. It's great.
Let's
Moving on. Let's do the question, shall we?
Right, let's take some questions. We have firstly a comment from Tsohofa saying, enjoying the physical science review show. It's awesome. Thank you so much.
Oh, you're welcome, sweetie.
Thank you. A question from Matsubane Minitifo. This guy is always funny. He's just a funny guy. You see what I'm talking about? Tracy's laughing while I'm talking about this guy. He's always funny.
We like funny guys. Yes.
He's fun to chat with on the page. He says, what are the coherent sources and an example, please?
Okay. A coherent source simply means that you've got a source that's completely in phase. So a laser is a coherent source of light. Okay, so coherent means that it's one frequency completely and utterly in phase. To get coherent sources, another way to do it, and sometimes they will ask you this, if I just get to a blank page, is for your double slits experiment. So you have two slits, okay, and if you have one light source that comes through the slit, these two, the 2 points of diffraction that come afterwards, they will be coherent. Unlike my diagram, okay? They will be coherent because they are completely and utterly in phase. But lasers are the best examples of coherent sources. Yeah.
Nice one. Okay, moving right along. Karabo says, when you round off your answer and have to use it in the next step, does it make a difference if you use the one stored in your calculator, not the one you rounded off?
Karabo, that's a very, very, very important question, okay? You must use the rounded off one if that is what you've substituted, okay? Because when the memo is done, and it's not that you're wrong mathematically, because you're not, but when the memo is set up for us, okay, that we use to mark from, the rounded off answer is used in the memo. So what you're trying to do is making sure that you're not losing marks for something that's quite silly, all right? So don't store in your calculator. I know you get taught to do that in maths and some of your other subjects, and that's fine, and it is definitely more accurate, but you must use the rounded off value. So whatever value you substitute into the equation, that's the value you must calculate using. Okay, that's really, really important, and I'm glad you asked that, Karabo, because it's a silly place to lose marks, and often it makes a slight difference in the values, and we get told that we can accept certain values because we take rounding off into account, and if it doesn't fit into those values, then we can't give you the mark. All right, and I know it sounds quite silly, but it's an accuracy thing. It's a decision that's been made, so you need to stick to that, okay? So great question. I'm very, very glad you asked that. Now, we've got one more question to do while I'm busy with it. Get on the Facebook page, ask AB some questions. Let's see if we can sort you guys out. Now, we're going to photoelectric effect. We haven't spent too much time this year on photoelectric effect. Such a nice section. Remember, it's always done in such a funny place in your exam. It's the last question. It's question 12, okay? So electromagnetic radiation has both wave and particle properties, which of course freaks us out completely. Name the phenomenon commonly used to prove the particle nature. There's only one thing we use at school, which is the photoelectric effect, okay? Photoelectric effect. Okay? Now it says, write down the term used for the particles of EM radiation. So we're not talking about waves, we're not talking about those sort of things, but what do we call those things? And we often refer to this when we get to the actual energy of things. We call it and we say that it is the photons. Okay, the particles of EM radiation, particles of light, are called photons. Okay, that's the particle name for it. Otherwise, it's known as a wave. Now we get to the fun part where things go a little off haywire. So what we have, I'm telling you, this board hates me. Okay, there we go. So the diagram below shows electrons are emitted from the surface of a metal using EM radiation. It's a really nice diagram. You've probably seen this in your textbooks. Here's the electrons. I know it's quite difficult to see. These are the electrons, these little round things that are being pushed off over here. Okay, and this is my wave. This is my light. Okay, or EM radiation. Remember, it doesn't have to be light. It can be UV light, infrared light. It all depends on the metal being used. Now they say the EM radiation has a wavelength of 410 times 10 to the minus 9 meters. Yay! So we know wavelength. The emitted electrons move away from the metal surface at a velocity of 7.5 times 10 to the 4 meters per second. Calculate the kinetic energy of the emitted electrons. Don't get freaked out by this. Okay? We take a deep breath. We go, hang on. They're not asking anything about frequency. They're not asking anything about work function. They just want kinetic energy. From your information sheet, okay, we get told that K equals a half mv squared. So we go fine. Kinetic energy, you can also be using EK. Okay, so it's given. Half mv squared, so we go fine. I know what a half is. Hang on, wait. Mass. No mass was given here. But they said it's the energy emitted it's the energy of the electrons. Electrons have a mass. You look it up on your information sheet, and it's a ridiculous mass, okay? So the mass of an electron, which I'm going to write here, is 9.11 times 10 to the minus 31 kilograms. You do not have to learn that. Make sure you can look it up, though. Do not confuse it with the charge. Please, if you're not sure, look at the table properly. The information table gives you it as a symbol, and it gives it to you as a word. It tells you what it is, okay? And I know the velocity, so that's actually quite simple. So that means I'm going to go a half times 9.11 times 10 to the minus 31. It's going at 7.5 times 10 to the 4. All of that is squared. Please, grade 12s, I'm asking, don't forget the square. So if we look at our calculator, which is going to come back up eventually, or not. So
Patience.
I'm being very... See, I'm telling you, this board does not like me today. Telling me I should have stayed at home. Anyway, so 0.5 times 9.11 to the minus 31, okay, times, now I'm going to do this in brackets so that I remember this has got to be squared, okay, and this is the 7.5 to the 4, which has to be squared, and look at that, 2.56 times 10 to the minus 21. It is tiny, 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 okay, has to be tiny. Electrons are ridiculously tiny little things, okay? I know it's going really, really quickly, okay? It's only about 100 times slower than light, but still, it's a very, 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 very tiny thing, all right? Why did they ask you to calculate kinetic energy for the next question? Because now they say to calculate the work function of the metal. Work function is H times frequency, threshold frequency. You were not given threshold frequency. You were given a frequency of light that resulted in energy being given to the electrons. Now remember that, and I'm going to take this off. When it comes to the energy, so the energy from the photon, okay, results in the work function plus kinetic energy. So the electrons, the wave has a certain amount of energy. The electrons first take the energy needed for the work function to be released. Whatever's left over is the kinetic energy, okay? E equals HF. Work function is what I'm looking for, and we have K. They were very, very nice in this question because this could have been asked as one question. Straight away, what is the work function? Now, remember, you do have the equation E equals hc over lambda, which is where we're going to have to go because I don't know F. You can calculate F separately, that's fine, but I'm just going to write here E equals hc over lambda. It's also on your information sheet. Remember, C equals F times lambda, so F equals C divided by lambda. Okay. Why are you doing this is probably the question. I don't like doing 4 million calculations if I can help it. I'm a bit lazy that way. H is a constant, okay, which you get off your information table, and it happens to be 6,63. Seriously, 6,63 times 10 to the minus 34. C is the speed of light, 3 times 10 to the 6. No, 10 to the 8. Lambda, which was given to you as, 410 times 10 to the minus 9. We don't know work function. We worked out kinetic energy, 2,56 times 10 to the minus 21. Or you have to do solve for WO. Okay? I suggest, okay, and this is my suggestion, let's work out what the bracket is, what this is. Okay? So it's 6.63 to the minus 34 times 3 to the 8 divided by 410 to the minus 9. And we get 4.85 times 10 to the 12. That can't be right because I made a mistake somewhere else. 6.63 to the minus 34 times 3 to the 8. There we go. Divided by 410. 410 to the minus 9. Much better. 4.85 times 10 to the minus 19. Okay. Okay. Plus 2.56 times 10 to the minus 21. So this is quite a ridiculous answer. So let's go here. So now, Karabel, this was your question. I'm going to use the 4.85 to the minus 19, and I'm going to minus, because this was addition, the 2.56 to the minus 21, and I get 4.85 times 10 to the minus 19. Okay? Doesn't actually seem to make any difference whatsoever. So my work function, and it's just because of the fractions. That's my work function. From here, if we were really mean, we could now ask you for the threshold frequency. Okay, because I know what work function is. So WO equals HFO, so we could work out threshold frequency if we really wanted to, but they weren't that mean. It was the last question. Do we have questions, Amy?
We have a lot of questions.
Okay, let's see how many we can get through.
All right. Here's this one. Clarence attempted to answer it, but I just want you to answer it
just
for
to
everyone.
double check, yeah.
Zacchaeus Bia said, It is said that Doppler effect is used in astronomy. Is it true?
Absolutely. That's such a nice question. It's another way we can use it. It's used to give evidence of the Big Bang Theory. It's redshift. It's what we use to show that the universe is expanding. Because when we look at the spectrum made by the sun, we should get a specific spectral line, and that spectral line is shifted to the red side, okay? Which means the wavelengths are longer than we expect. And we know what stars and stuff are made out of, so we get that redshift, which means everything is actually moving away from us. So we say the universe is expanding, and some people use it as evidence of the Big Bang, basically. Yeah.
Very, 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 very nice one.
Oh, I particularly enjoy that. I like astronomy, so yes.
All right, here's a general one
Yes.
From Caroline. She says, using scientific terminology, explain why the sky appears to be blue during the day.
Wow, that's scattering, Sweet Pea. It's actually a really good question. It's one they haven't asked in a while. But remember, as light comes from the sun, which is the entire spectrum of the colors, it hits water droplets and dirt and dust and everything inside the atmosphere. As it comes through, some of the light gets absorbed by the atoms, okay, and then some of it gets re-emitted. And when it gets re-emitted, it's blue light that gets re-emitted, and it gets scattered all over the place, so that when we look up, we see the blue light being scattered everywhere, okay, and that's why we see the blue sky, and it's because of the size of the water droplets and the dust and everything else. It's also why at sunset we get a red sky, because it has to go through more atmosphere. The blue gets scattered up so we don't see it, and the red light's able to come straight through to us, basically.
Right. The mindsetters don't want us to go. They say we should end the show at 8 o'clock.
By then I'll be like crying. Yes.
Here's a quick one from Gaugelo. How do I calculate threshold frequency?
Okay, sweetie, from here, if I wanted, and I'm not going to do the calculation because we are going to run out of time. Remember, threshold frequency is work function, h times threshold frequency. Okay, so I would, in this case, put in that value. H, I know it's a constant, and then solve for f. Okay, I don't actually think I have time for another question. No. Guys, well done. Remember, we're back on Saturday. We think 10 is the science. We're going to do more of the paper. So make sure you tuned in. It's going to be live as well, so we'll be able to answer some of your questions. And that's an hour and a half, I think.
Yes, we're starting from 9 o'clock, and then there's another show at 10:30. It's actually the whole day from 9 up until 6 p.m. And there's some repeats. Oh, gosh, that's a Tracy effect. There's some repeats later on. It's not a technical error. I don't know. What is it? There's some repeats at 9 o'clock in the evening, so make sure that you don't miss out on that one. Still use the help desk. Otherwise, from us, we just want to say thank you to Macmillan and Yip. Yours in peace, AB and Tracy. No
anyway,
problem.
moving on. Guys, seriously, make use of the fact that you can get our notes, that you get everything's there. Make use of mindset. This is your last big push. You've got about 4 or 5 weeks before we write your finals for this one.
Yes.
It's okay. Last big push. Now, like AB said, we're going to do a little bit of physics prelim review, and specifically we're looking at the GDE prelim. So those of you who wrote the prelim, hopefully you got them back today. So you've maybe had a little bit of review with your teachers. I don't know. Those of you who are from other provinces, you know what? That's okay. You can bear with us. Remember, these notes are online, so you can actually get them. So if we start, what we're going to do is we're literally just going to do some questions from the 2013 prelim exam. Okay? And what we've done, we're not going to do them in order. So I'm not starting with question 1 and question 2 and the one-word answers. What we've decided to do is we decided to pick out the sections that we feel, and I'm obviously looking at it from my own learners, I have quite a few, but also the things we feel like where the common mistakes would come in, and the sort of questions that might have been a little trickier, a little different to what you're used to. So and practicing under exam conditions,
yes.
Not with your book open. So the more you practice without a book and get them right, the more confident you're going to feel.
Nice one. Talking about revision, Mindset has partnered with Samsung to make sure that you have your revision package all handy at all times. Now I'll be taking you through to the Samsung Learning Hub, how it looks like. You can access it on your Samsung tablet or your premium smartphone. This is how it looks like. When you get to the material that you like or the content that you like, you'll see a document more like your own question, your normal question paper, and then you can browse through on it. You can answer the questions. It's interactive. I can answer in it. Then the nice part also about it, you see, I can see my answer if I'm wrong or not. Can also check the marks. But the nice part of it is that you can also check the videos. As you saw that I was having a video that was playing. You see a video at the same time. You've got two screens that are playing at the same time. How nice is that, Tracy?
Oh, man.
Because at times you're working and you have only one device that you're using, so you can't see the video and the question paper at the same time.
I think it's great. I just think in terms of that's who doesn't have a tablet these days, pretty much.
Or a smartphone anyway,
of some sort, yeah.
A premium smartphone. But it doesn't end there. As you see the video that is playing on your device, you can also view all the material that we have. So this is how you view the material. You go to the Learning Hub, your Samsung Learning Hub on your tablet, and then you go to you'll see a shelf with the books that you have. If you don't have any other books, you still have some space to put on more books or content. You go to the store. When the store opens, you'll see there's a category and brands. What you do is you go to brands. You'll see all the brands that are there and look for Mindset Learn. Then you click on Mindset Learn. When you click on Mindset Learn, you'll see all the products that Mindset has. You can view them and you can also purchase them. So for instance, you view that you like life sciences and then you'd like to see what more do we have on biotechnology. You can view that and then you can also buy it. We have a free voucher that you can access, which is worth $100. So learning is easy and accessible. And once you purchase this, it will be on your bookshelf and you can access it at any time. That's a great innovation from Samsung.
That's amazing. And 100 Rand with things only being what, 8, 9 Rand?
8 Rand 37.
That's like you can get 10, 12.
So many stuff.
Books and stuff. It's unbelievable. I think it's actually
I'm
amazing.
glad you mentioned that, Tracy, because on that voucher, you need to use it once and you need to use all of it. If you just use 10 Rand, it means you'll lose 90 Rand. So better use it all. But without any waste of time, as Tracy have said that we are going over some prelim reviews, I need to tell you that it is proudly sponsored by Macmillan and you can have your notes all for free on learnextra.co.za/live. Otherwise, chat to me on Facebook. Our Facebook page is facebook.com/learnextra. Like the page and let's get interacting. But otherwise, we have also the help desk where you can submit your questions on Mixit, now available on Mixit. Look for it under the general contacts, add it because we always want to help you. Thanks a lot to Macmillan for making this show possible. Tracy, over to you.
Thank you. Sorry, I'm just busy getting a bit lower.
Hello to you all awesome matriculants. Welcome to This is Learn Extra Live, your favorite show, and it is all about physical sciences. My name is AB, better known as Abram, but I'm joined by Tracy. How are you, Tracy?
Fine, and you, AB?
I'm also good. It's the last term. How are you feeling? I heard you were crying.
Why?
Because it's the last term.
Well, you know what? All my babies are darn grown up now.
Okay.
I told them today. When I saw my babies, I was like, they all did go grown up now.
Aww.
And so all my babies are adults, and I miss my baby.
Well, there's no more time for them except revision now. There isn't much work that they need to do except revising.
Revise.
Are you feeling good though? Do you think they are ready in a way?
You know what? I think it depends on how much they've done. So if they take note of what you're doing the next couple of shows, like today and Saturday, we're going through the physics prelim paper, art questions. We can't do all of it. It was a long paper. But now it's just revision, practice.